transformations of primary trig functions. We're going to understand how to graph transformations of primary trig functions. To understand that, let's look at the general equation of a transform function, y equals a sine k times x minus d plus c, or y equals a cos k times x minus d plus c, where a, k, d, and c are the translations. A and k are the horizontal and vertical compressions or stretches, and d and c are the horizontal and vertical translations. We're familiar with these values and transformations. When mapping a sinusoidal function, the pre-image function, if it has theta comma y as its coordinates, then to map the changes, you do theta divided by k plus d for the changes that happened horizontally, and a times y plus c for the vertical changes that have happened. So let's look at this question. It's not very clear over here. This is y equals 2 times sine 3 theta plus 1. Okay, so that is the function that we have to graph, and we have to graph it for one period. So what we're going to do is first we're going to do the mapping from the parent function theta comma y. As we can see that the horizontal stretch is 1/3, so it's theta divided by 3, and there's no shift horizontally. For y, there's a stretch factor of 2, so 2 times y, a shift of 1 up, so 2y plus 1. So that's our mapping. And we're going to start off to graph this by first finding the key points that we have in the parent function. The parent function is y equals sine theta. So we know what the values are for sine theta. We know what sine 0, pi over 2, pi, 3 pi over 2, and 2 pi are, right? So 0, 90, 180, 270, and 360. We write those values 0, 1, 0, -1, and 0. And then we apply our transformation. So every theta gets divided by 3. So this ends up being 0. When you divide this by 3, this becomes pi over 6. Divide this by 3, it becomes pi over 3. Divide this by 3, it becomes pi over 2. And divide this by 3, you get 2 pi over 3. The y values, multiply each of them by 2 and add 1 to it. So you get 1 here. 1 times 2 is 2 plus 1 is 3. 0 times 2 is 0 plus 1 is 1. -2 plus 1 is -1. 0 plus 1 is 1. So now that we have it, we can now graph the transform function. Now what we have in blue here is the parent function. You can see that it starts at the origin and it completes one cycle in 2 pi radians. So the period is 2 pi. And for this function here, 0, 1, the first point is right here. Then pi over 6. So this is 2 pi. This one is pi over 2. This is pi over 4. And we've got to find where pi over 6 is. So if you divide, this is our 90. This is our 45. Pi over 6 is like our 30. So it would be taking our 90 and dividing it into thirds, right? So if this was our pi over 2, so I would have a 30, 60, and 90. So 1/3, 2/3, and 3/3. Okay, so our 30 would be here. This would be our pi over 6. So that pi over 6 and 3 will be a point right up here. And then we have pi over 3, and that's our 60, right here, and 1, so that will be this point here. Then we have pi over 2 and -1, which is our point right here, 2 pi over 3, and 1, so that's like our 120. So 30, 60, 90, or 120 would be somewhere here, and that corresponds to 1, which is this point here. Okay, so just going to highlight that point in a different color so we can see it. So we start off here, 1, 2, 3, 4, 5, and that's how we complete one period. I'm going to do that in red. Just do a dotted line first to see how it looks. Try to draw a smooth sinusoidal function there, and that is for one period. So it completes one period in 2 pi over 3 radians. We're going to now compare the key features of the original function and the image function. In the original function, it completes one period in 2 pi radians. The equation of axis is this axis here. It's kind of like the axis, horizontal axis that kind of divides this into 2 halves. It's the x-axis, which has the equation y equal to 0. The amplitude is this distance between the equation of axis and the maximum, or the equation of axis and the minimum. As you can see, it is 1. The maximum value for the parent function is 1. The minimum value is -1. So in order to find the equation of axis, which is your y equals c value, and your amplitude, which is your a value, so c and a are the same things we see when we do vertical stretch and vertical translation. There is a formula to kind of help us connect the two. So our a value would be, or the amplitude is m, our maximum value. Let's call this capital M for maximum value and lowercase m for minimum value. So if we do m minus m divided by 2, we get the amplitude of our function. And to find the equation of axis, or our c value, we do m plus m divided by 2. So those are two formulae you can remember. So in our function, if we did m minus m, we get 0 divided by 2, which is 0. So, sorry, 1 minus -1, which is 1 minus -1. You get 2 divided by 2, which is 1. So our amplitude is 1. And our equation axis is m plus m divided by 2. So 1 plus -1, which is 0, divided by 2, which is 0. So that's our equation of axis is 0. Looking at the diagram here in red for our transform function, you can see it completes one period in 2 pi over 3 radians, right? And its equation of axis is the line that divides it into 2 halves. So it actually is falling right here, right? It has a different line which has the equation y equals 1. The amplitude is the length from the equation of axis to our maximum or our minimum point on the sinusoidal function. So if you look at the distance from the equation of axis to here, or the equation of axis to here, you can see the amplitude is clearly 2. The maximum value it can go up to is 3, and the minimum it goes up to is -1. And if you wanted to check our answers also, we can see if we did 3 minus -1 divided by 2, we'd get 4 over 2, which is 2. And that's our amplitude, which we have here. And if we did 3 plus -1, which is 3 minus 1 divided by 2, we'd get 2 divided by 2, which is 1, which is our c value, y equals c. Okay, so that way we can know that we can find our a and c values from the maximum and minimum values of our sinusoidal function. We're going to do the same thing, but this time for a cos function. Y equals -3 times cosine. Let me write that again here so you can see it clearly. Y equals -3 times cosine of 0.5 times theta minus pi over 6. Okay, so we're going to now do the mapping. Our original pre-image function is theta comma y, and we can see that there are changes made to it based on these transformations. So our horizontal ones are going to be 1 divided by 0.5, which is 1 divided by half, which is 2 theta, 2 times theta, and it's moved pi over 6 radians to the right. So 2 theta plus pi over 6 for our horizontal changes. And our y values get multiplied by -3. There's no vertical shift, so it's just -3y. So that is our mapping. We have the original key points for our parent function y equals cos theta. So it goes from 0 to 2 pi, going up by pi over 2 each time. Cos 0 is 1, cos pi over 2 is, cos 0 is 1, cos pi over 2 is 0, cos 180 is -1, cos 270 is 0, cos of 360 is, again, 1. So applying these transformations, we can get the table of values for the image function. We're going to multiply every angle with 2 and then add pi over 6 to it. So 0 times 2 is 0 plus pi over 6 is pi over 6. 2 times pi over 2 is pi. Pi plus pi over 6. How much is pi plus pi over 6? That becomes 7 pi over 6. 2 times pi plus pi over 6 will be 2 pi plus pi over 6. That will be 6 to the 12 plus 1, 13 pi over 6. Then 2 times 3 pi over 2 is 3 pi. Plus pi over 6 is 6 3s are 18 plus 1, 19 pi over 6. And 2 times 2 pi is 4 pi. Plus pi over 6 will be 6 4s are 24 plus 1, 25 pi over 6. So there I have all the transformations to the theta. Now I'm going to calculate what the mapping helps me to figure out the y values are. So every y value gets multiplied with -3. So this becomes -3. This becomes 0. Sorry, this is +3, not -3. Yeah, it is -3. It is -3. 0, -3 times -3 is +3, 0, and -3. I'm going to graph this function. Let me just take away these calculations here so it doesn't look so messy. And I'm going to then graph these points right here. I have my parent function in blue. So that's one period from here to here in 2 pi radians. You can see that I'm going up by like pi over 6 each time, which is like 30 degrees each time. So I need to kind of figure out where pi over 6 would be. So this is pi over 2. This would be, dividing this into 3 parts. This would be pi over 6. This would be 2 pi over 6. This is 3 pi over 6 or pi over 2. 4 pi over 6, 5 pi over 6, 6 pi over 6. Okay, so this is my 6 pi over 6, which is the same. Sorry, am I doing it right? 1 pi over 6. This is pi over 2. 3 pi over 6, which is pi over 2. 4 pi over 6, 5 pi over 6, and 6 pi over 6 should be then pi. So there's something off there. Let's me start over again. This is pi, and this is 2 pi. So my one cycle goes from here to here. So this is pi. So this would be, there's where I went wrong. So this is not 90, this is 180. So that's, this would be pi over 2. So that would make pi over 6 right here. 30, 60, 90, and it goes up by 30 degrees each time. Okay, so 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So the reason I do that is so I can easily now plot the points, right? So if I want to do pi over 6 and -3, that would be this point right here. Let me do that in a different color. Let's use purple here. And then 7 pi over 6 will be 1, 2, 3, 4, 5, 6, 7 pi over 6 and 0 is this point here. 8, 9, 10, 11, 12, 13 pi over 6 and 3 will be up here. 14, 15, 16, 17, 18, 19 pi over 6 and 0 is back here. 20, 21, 22, 23, 24, 25 is -3, which will be down here. So now I can see that there is a huge stretch happening here, right? So I'm starting off over here, going to this point here, then coming down and completing one period. That's because, and you can see it's shifted pi over 6 units to the right from where it was in the parent function, and there is a stretch, right, which is why it's now having a bigger amplitude. And also there is a -3, which means there's a reflection in the x-axis. So it starts off here, not at a, it starts off at a minimum, not at a maximum like it did in the parent function. So this is one cycle of the parent function. I'm going to now compare the two. So the original function, its period is one cycle is completed in 2 pi radians. The equation of axis is the x-axis, which is y equals 0. Amplitude is 1, maximum value is 1, minimum value is -1. In the transform function, what is the period? It completes you can try to do, subtract this from this and find the period. Another way you can find the period is to do P is equal to, let's do that in purple for the transform function. P is equal to 360 or 2 pi divided by K. Let's do it in radians. Period is 2 pi divided by the K value. And in this case, it is 2 pi divided by, what's our K value here? 0.5. So that ends up being 2 divided by half is 4 pi. So our period is 4 pi. Okay, so we can use this formula here, 2 pi divided by K, to get the period. We could have also taken this value here, 25 pi over 6, and subtracted pi over 6 and got the period. So if I did it that way, which is 25 pi over 6 minus pi over 6, I would get 24 pi over 6, which is 4 pi. So both of those answers yield me a period of 4 pi. The equation of axis now, I can try to calculate it by using the formula, or I can use the graph. So by using the formula, what is the formula for A? It is m minus m divided by 2, right? So the maximum value you can see here is 3. The minimum it goes to is -3. So the amplitude is 3 minus -3 divided by 2, which is 6 divided by 2, which is 3. So it's y equals 3. And the, sorry, I should write it here. A is equal to 3, not y equals 3. And for the equation of axis, it is m plus m divided by 2, which is 3 minus 3 divided by 2, which is 0. So y equals 0. So if you look over here and you try to find the amplitude, let's show that here. This would be the equation of axis, which is still y equals 0 for our transform function, and the amplitude is 1, 2, 3. So you can see that the a value is 3 here, a value is 3 here, equation of axis is y equals 0. Next, we're going to graph the tangent function with the transformation over the interval 0 to 2 pi. This is the transform function, y equals -tan of theta plus pi over 4 minus 1. I'm going to change this up a bit and write a different formula here. I'm going to change this to pi over theta plus pi over 8 minus 2 and do that one instead. So it's a transformation of the parent function y equals tan theta. So my parent function theta comma y, what is the mapping? So I'm going to look for this and this and this, and I can see that for horizontal changes, there is theta minus pi over 8. So horizontal shift of that much to the left. And for vertical changes, there's negative y minus 2. My parent function is y equals tan theta. It's the graph in blue that you see here. And I have one cycle that is going from 0 to pi. And I have to graph this for 0 to 2 pi. Okay, this particular tangent function. So I'm going to go from 0 to pi, the actual values from the parent function. Tan 0, 0, tan pi over 4 is 1, tan 90 is undefined, tan 3 pi over 4 is negative 1, tan pi is 0. I'm going to apply the transformations to the x values here. I'm going to subtract pi over 8 from each of these x theta values. I'm going to get negative pi over 8 here. Pi over 4 minus pi over 8 gives me pi over 8 here. Pi over 2 minus pi over 8 gives me 3 pi over 8 here. And here 3 pi over 4 minus pi over 8 gives me 5 pi over 8. And here pi minus pi over 8 gives me 7 pi over 8. Multiply every y value with negative 1 and subtract 2. I get negative 2 here, negative 3. Can't do any calculations here, it's undefined. Negative 1 and negative 2. Now I'm going to graph those points. Negative pi over 8, positive pi over 8. So this is my 0 and this is my 2 pi. That makes this my pi. I have to divide it into 8 parts to get pi over 8. This is, pi over 2. So each part gets divided into 4 parts. So each of these is pi over 8, right? Pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, which is the same as pi over 2. Then 5, 6, 7, 8 pi over 8, which is the same as pi. Then 9 pi over 8, 10, 11, 12 pi over 8, 13, 14, 15, 16 pi over 8, which is the same as 2 pi. So I just divided it accordingly. My negative pi over 8 will be right here. Okay, so I'm going to start my first plot. Let's try it in purple. Negative pi over 8 and negative 2 will be down here. Pi over 8 and negative 3 will be down here. 3 pi over 8, 1, 2, 3 pi over 8, and the y value is undefined. So what happens here is there is a vertical asymptote happening right here. Okay, then let me go back to plotting. 5 pi over 8, so 1, 2, 3, 4, 5 pi over 8 and negative 1. So I have this point. 6, 7 pi over 8 and negative 2, 5, 6, 7 and negative 2, which is this point here. And if I continue that pattern, I'm going to find that after 7 pi over 8, it can get some more points just because I want to get some more to kind of plot up to 2 pi. Okay, so I'm going to do that right here. Continuation of this just to get more points for theta and y. So 1 pi over 8, 3, 5, 7. So next would be 9 pi over 8, 11 pi over 8, 13 pi over 8, and then 15 pi over 8. And that pattern is going to repeat. 2, negative 3, undefined, negative 1, negative 2. This is going to be negative 3. And then undefined, where the asymptote happens, the negative 1 and negative 2. So the points are going to be pretty much repeating like that. So the next point is 9 pi over 8. So that's 8 pi over 8. 9 pi over 8 is negative 3. So it's going to be down here. 9, 10, 11 pi over 8 is undefined. So that's where my vertical asymptote happens. So 8, 9, 10, 11. So right here. Just got to move it a bit so it's right there. Then, so 8, 9, 10, 11. 13 pi over 8 and negative 1. So that will be this point here. 13, 14, 15, and negative 2. So it's down here. And I can also take one more point, which is the, 17 pi over 8, which will be after the 2 pi. And that would be negative 1, negative 2, then negative 3. So that would be beyond this, 17 pi over 8 and negative 3, which will be down here. So you can see that there is a vertical asymptote and the points are kind of like this, right? So they come and they try to meet the asymptotes like that. So you can see one function right here. Similarly here, I have just these 2 points that are approaching. But if I want, I can extend them up like that. Similarly over here, these points show me that it's going to be approaching the next vertical asymptote like that. It's going to be going up like that. So this is the function that we're given y equals negative tan theta plus pi over 8 minus 2. Okay, the blue is the original parent function. In the original parent function, the period is pi. You complete one cycle in pi radians. The equation of axis is y equals 0. Amplitude, there's no amplitude, is undefined. There's no maximum minimum value, so none. And in the image function that we graphed, the period, the time taken to complete one cycle, is also pi. We could use the formula that we had, which is 2 pi divided by k, right? 2 pi divided by k value. This one, it's still So one period is from here to here. It repeats the cycle. So let's say pi to this point here. So that would be pi over 8, 10 pi over. It still stays as pi. The equation of axis is still y equals 0. If you look over here, what is our new equation of axis? Because we can see that there's a c value of negative 2. So it is y equals negative 2. There is no amplitude. There is no maximum. There is no minimum. So those are our values for our function compared to the tan function. So in this case, the period will be pi over k, not 2 pi, because it completes a cycle in pi radians. So it will be pi over k value of 1, which ends up being pi. So if you use the formula, we would stick with, one cycle in the parent function is completed in pi radians, so pi divided by 1 is still pi. So in general, for y equals sine theta and cos theta, we notice these characteristics. Okay, I've written the changes in amplitude here, and then the y equals tan theta changes on the second column because they're kind of different. So in general, the amplitude is your A value. Your period for the sine or cosine is 2 pi over k. For the tan, there is no amplitude, and our period is pi over k. Okay. Then the phase shift, which is how many units it's moving, is your d value. And same thing here. Equation of axis is y equals whatever your c value is. Same thing here. The maximum value is your equation of axis plus your absolute value of your amplitude. And the minimum value is equation of axis minus the absolute value of your amplitude. Here, you don't have a maximum or a minimum for the tan. So in general, these are how you notice the key characteristics of your transform function R. So we're going to fill in the chart here for some functions just to practice the mapping and what they look like. So for example, if you had y equals sine theta, and these are the transformations happen to it, what is the mapping going to look like? When I see this, I notice that the 2 is not factored out. So for this one, I need to do some work before I can get the answer. I need to rewrite this by factoring the 2 out. So that's y equals -3 sine of 2 times theta plus pi over 4, right? Because 2 times pi over 4 will give me pi over 2 plus 4. So now I can clearly see all the changes. So my theta y in the parent function sine theta has become theta divided by 2, whatever, because the k value is 2, minus pi over 4. And my y value is -3y plus 4. Okay. Here, theta y becomes, there's no change to, there is a k value here. Let me take that out also. So again, here, there's a bit of work. This is y equals 2 cos of a half, or factor out the half, times theta minus 2 pi over 3. Because half times 2 pi over 3 will be pi over 3. So I can clearly see now that every theta value gets multiplied with 2 because it's theta divided by 1/2, which is 2 theta, and goes 2 over 3 units to the right, so plus 2 over 3. And y values get multiplied by 2, and that is it. There's no translation vertically. Here also I can see y is equal to 1/2 tan of 2 over 3 pi theta. So there is there's nothing to factor out because there's no horizontal shift here. So theta y becomes theta divided by 2 over 3 pi, which is 3 divided by 2 pi. And every y value gets multiplied with half. So y divided by 2. Okay. These ones, they're giving me the mapping and they want the image functioned. So this would be y equals negative, right? And it's sine theta, so sine. And my k value is, the reciprocal of that. So it will be 1/2 brackets theta. Since it's plus, that means it's minus pi over 6. Because I have a half, yeah, it's minus pi over 6, yeah. And then there is a plus 1. Okay. And here, there's a k value, there is a d value, there is a value, and there's a c value. And it's the transformation of a tan function. So y equals 2 times tan. So that takes care of the 2. And the k value here is reciprocal of that. So it'll be 3 times theta minus, so it's plus, so it's moved, so minus pi over 4 minus 1. In this example, we're given a graph and it asks to find what is the equation of this function. Okay, so it's telling us that it has 1, 2.5 cycles, so 2.5 periods, and that is completed in 25 over 12 pi radians. Okay, so that's the case. The period 2.5 times p equals 25 over 12 pi. So period is 12 times 2.5 divide 12 times, sorry, what am I doing here? 25 divided by 12 times 2.5 pi. And so that works out to, in lowest terms, 10 over 12 pi. Okay. Or even further lowering it to lowest terms, 5 2s are 10, 6 2s are 12, 5 over 6 pi. So that's the period. And to find the c value, we can try to draw a line that gives you, so there's 1, 2, 3, 4. So obviously the equation of axis has to be halfway between that. So this is the equation of axis, which will have the equation y equals -1. All right. Our maximum value is 1. Our minimum value is -3, right? So if you did 1 minus -3, you get -2 divided by 2, which is -1. So c is equal to -1. And our a value, or amplitude, is the distance from here to here, which is clearly 2. So to find our, and we have to see where it starts. It starts right here. So it's like a sine function. It starts right there. So our d value is 0. So I have a, I have c, I have d, and I need to find k. So k is going to be 2 pi divided by the period, because, you know, p is equal to 2 pi over k, so k is 2 pi over p. I found out the period to be 5 over 6 pi. So that is, the pi and pi cancel out. 2 divided by 5 over 6 is the same as 2 times 6 over pi 5, which is 12 over 5. So I have my k value, which is 12 over 5. So now my function, it is a sine, a transformation of sine, because it's starting as sine does, okay? And so it's going to be f of x, or y, equals 2 times sine 12 over 5 theta minus 0 plus minus 1. Or I can write this as 2 sine 12 over 5 theta minus 1. We're going to do the same thing for another question here. You can see it looks like a transformation of a cosine function starting at a maximum. So 1 cycle, 2 cycles are completed in 4 radians, right? So you can see that 1 cycle is completed in 2 radians. The period is 2. P is equal to 2 pi over k. So k is equal to 2 pi over p. K is equal to 2 pi over 2, which is pi. And our equation of axis, our maximum value is 4. Our minimum value is -2. So equation of axis is 4 plus -2 divided by 2, which is 2 over 2, which is 1. So our equation of axis is this line here, right? And our amplitude is a distance from here to here, which is 1, 2, 3, 1, 2, 3. We can clearly see amplitude is 3. Or we could calculate it and say it is 4 minus negative 2 divided by 2, which is 6 divided by 2, which is 3. And so we have A, we have K, we have C, and there's starting here, so the D value is 0 for cos. So our function is y equals A cos pi theta plus 1. Okay, there's no D shift, and that's it. Okay, so that's one way to look at it. We can give that as our answer. You can also give this as a sine function. Okay, so if you think of it as a sine function, sine functions, they start off right here, isn't it? It's starting right here. Or you could have it start right here, right? If you think of it as a translation of a sine function, it would look different. So another answer could be, this happens because we have these periodic functions. Another answer could be like a translation of sine. So we would say then that it has shifted, 0.5 units to the left. So they'll have a D value of 0.5. The amplitude would still be A would be still 3. Our K value would still be pi, and it would have a C value of 1. So then it would look like y equals 3 sine pi times theta minus 0.5 plus 1. So you could also have an answer like this if you were trying to see it as a translation of the sine function. This would be, so our D value is actually here. Since we're looking at it moving here to the left, our D will actually be negative 0.5, so this will be plus. Okay, so it's shifted 0.5 to the left. So there's two ways you can look at it, depending on if you want to have as the basis of cos or sine. This is easier than this, so we could just stick with cos. You can now try the practice.